the binomial expansion, the binomial coefficient. So in this video and in the video that follows this one, I'm going to review some basic facts about binomial coefficients, which you should already be familiar with because this was already introduced in the chapter called Counting and Probability. So we talked about these, about combinatorics actually, and when introducing those concepts, various notations were used, and now I'm going to review them. So, important note, the set of natural numbers consists of numbers 0, 1, 2, 3, etc. This is the convention used in our textbook. But be aware of the fact that in some Slovak textbooks, 0 is counted out. It's not taken as the natural number, but here we will take it to be the natural number. Okay, so first let us start with the n factorial. N factorial, denoted as n and this mark here, exclamation mark n factorial, is defined for numbers n from the set of all natural numbers by the following definition. Okay, so before I start with the definition, let me give you an example what it means. So what can the n factorial be? For example, let us consider number which is 4 factorial. Okay, this is 4 factorial, or 3 factorial, or 100 factorial. This is how we read such numbers. So you say the number and then say factorial. In general, you can have n factorial. Okay, so what is the n factorial? The definition is the following. N factorial equals n times n minus 1 factorial if n is greater than 0, and it equals 1 if n is 0. So let us try to understand this. This is quite an interesting definition. It's the so-called recursive definition. It uses factorial to define factorial, but not the same factorial, but one number less factorial. Okay, so let me give you first the idea what means the second line. If n equals 0, then n factorial is 1. So what it says is the following. It says that 0 factorial, because n is 0, it says that 0 factorial is 1. By definition, we are defining 0 factorial to be 1. Now imagine you want to find, for example, the 4 factorial. 4 factorial, you look at this number 4. 4 is greater than 0, therefore I'm going to use this first line of the definition, and it says that the 4 factorial should be 4 times, it's 4 times, and there is 4 minus 1, which is 3 factorial. Okay, so I'm going to be able to evaluate 4 factorial if I'm able to evaluate 3 factorial. Okay, but how do I know what 3 factorial is? Okay, let's again use the definition. 3 is greater than 0, and hence I will use the first line. 3 factorial here, so let me copy 4 times, and 3 factorial here should be, according to the definition, 3 times, and there I should have 2 factorial, because 3 minus 1 is 2, so 2 factorial. Again, I'm in trouble because I can't evaluate 2 factorial at the moment. So what is 2 factorial? 2 is greater than 0. So I will use this again to define it. So let me write it below. It's 4 times 3, so I just copy the first part of the expression, times. And now the 2 factorial is going to be 2 times, and 2 minus 1 is 1 factorial. 1 factorial. Okay, I still don't know what 1 factorial is. So let me copy everything. It's 4 times 3 times 2 times. And now, instead of 1 factorial, since 1 is still greater than 0, I will use this. So it's 1 times 0 factorial. But 0 factorial is known from the second line of the definition, and it is 1. Okay, so what I need to do, I have to multiply 4 times 3 times 2 times 1 again. And what I get is, well, let me see, 4 times 3 is 12, times 2 is 24. So it means that 4 factorial is 24. In this example, you also can see easily that there is an alternative way how to define n factorial. N factorial can be defined as the product of n times n minus 1 times n minus 2 times n minus 3 and so on times 3 times 2 times 1. So you see it's a product of all numbers starting with n and decreasing by 1 until you reach 1, and then you stop. So this product here is n factorial. This recursive definition is very elegant, but it's harder to use. This one is very easy to use, but some people may have trouble to use it, for example, for number 2, because if you have n equals 2, then this first term is 2, this one is 1. This would be, well, 0, but that's not the case here. We have to understand that if n is 2, then we just take this part of this product, not the first few factors. Okay, so this is it for the factorial. Now, here is an example in which we have to calculate the factorial. So already I have calculated 4 factorial, but let me do it again using this second definition. So 4 factorial, according to this simpler definition, is 4 times 3 times 2 times 1. And we know that it's 24. Let's do part B. In part B, we have to calculate the fraction 5 factorial over 3 factorial. So the easiest way to do it is to write it as follows. It's 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. And since this is also here, we can just cancel it out and have the answer 5 times 4, which is 20. Okay? Now, in part C, we have even harder expression, 7 factorial over 4 factorial times 3 factorial. So, how to evaluate? So it's 7 times 6 times 5, and I don't need to write all the other factors. I just replace them 4 times 3 times 2 times 1 by 4 factorial, like this. Okay, because 4 times 3 times 2 times 1 is 4 factorial, divided by 4 factorial, and then I have to explicitly write 3 factorial, so it's 3 times 2 times 1. This is cancelled, okay? Now 3 times 2 is 6, so 6 can be cancelled with those two, 1 can be ignored, and we have the result 7 times 5 over 1, which is 35. So you see how simple this is. You should already be able to solve these exercises easily, but I'm just doing it to remind you of this stuff so that you can revise the basic ideas and become competent and proficient in using them. Now, the second theoretical part, the binomial coefficient. Binomial coefficients can be calculated using this formula, so don't worry about this middle part. Just take that n choose r, this is how we read it, n choose r equals n factorial over r factorial times n minus r factorial. Now, if one rewrites this thing here, so n factorial over r factorial times n minus r factorial, if I rewrite it, what I can get is the following. I can start with n times n minus 1 times n minus 2 and so on until I come to the term n minus r plus 1, and then there is the term 1 less, which is n minus r, and so on and so on. But these terms, these remaining terms, are just n minus r factorial over r factorial, which is r times r minus 1 times etc. times 1 times n minus r factorial. This cancels with this, and what I end up with is just this, which is this middle part written here. So it's n times n minus 1 etc. until n minus r plus 1, and there in the bottom we have, in the denominator, there is r minus 1, r minus 2 until 1. So this is the definition of the so-called binomial coefficient. These binomial coefficients are very important because we are talking here, we are on a chapter called the binomial expansion, and you already know that the coefficients of the expansions are the numbers in the nth row of the Pascal's triangle. So incidentally, these are actually the binomial coefficients in the form n choose r. Okay, n choose r. In Slovak we say n nad r, n nad r. In English, n choose r. Now, what is the meaning of this? This number, n choose r, represents the number of combinations of n distinct symbols taken r at a time. So to remind you of that, imagine you have a set with 5 letters A, B, C, D and E. You have 5 letters and you want to create combinations of these 5 symbols taken 3 at a time. So you want to create all the subsets consisting of 3 symbols. So A, C, E, for example, would be 1. Then you could have A, B, E, and so on. And the question is, how many of those are there? These are called combinations of n symbols, in our case of 5 symbols, taken 3 at a time. And the number of those should be, according to this, 5 choose 3. Okay, 5 choose 3. This number. And this is then 5 factorial over 3 factorial times 5 minus 3 is 2 factorial. So this should be the number of combinations of n distinct symbols taken r at a time. Now, to remind you again what a combination is and what is the difference between combination and permutation. Combination is a selection of objects. So here we have selected objects in 2 different ways. Actually, I can repair this so it looks better. Okay, again. So we have made combinations of 3 symbols. We selected 3 symbols, 3 objects from this set without regards to order or arrangement. So it didn't matter what the order of selected object was. So the combination ACE is the same as the combination CAE. These are the same. The order doesn't matter. There are groups of symbols, there are selections of objects that take this order very seriously, and these are permutations. But this is not about permutations, this is about combinations. So the combination, sometimes in Slovak we call this kombinačné číslo, so combinatorial number in English perhaps, but more usual name is binomial coefficient, and in Slovak binomický koeficient. Okay, so binomial coefficients are what we are going to talk about, and we are going to use them a lot. Now, to give you an example how to work out the binomial coefficient, the value of the binomial coefficient, let us use the formula to evaluate 5 choose 2. 5 choose 2, okay, so it's in part A. So according to the definition, which is here, I can rewrite it so that you can see it. N choose R should be n factorial over r factorial times n minus r factorial. So in our case, n is 5, so 5 factorial on the top over r is 2, so we have 2 factorial here, and n minus r, so 5 minus 2 is 3 factorial. Now we can rewrite it. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 3 factorial, divided by 2 factorial is just 2 times 1 times 3 factorial. This is just copied. This cancels out, and you see that the answer is, well, we can also cancel number 2 here and get 2 here, so it's 5 times 2, it's 10. Okay, so there are 10 combinations of 5 symbols taken 2 at a time. Okay, now in part B, we have 11 over 7 factorial, 11 choose 7, okay, like that. So according to the definition, n is 11, so we have 11 factorial over 7 factorial, which is this number r here, times, and we should have n minus r. So 11 minus 7, well, it should be 4, so there is 4 factorial. Now, we can rewrite it. 11 factorial and 7 factorial, these are the largest factorials, so I will write it as 11 times 10 times 9 times 8 times, and the remaining factors, they form the 7 factorial, divided by 7 factorial without any change because it's already here and we want to cancel it out, times 4 times 3 times 2 times 1. Now, cancelling this out, what remains is to work with these numbers and try to simplify. For example, 4 times 2 is 8. 4, 2 is 8, so I can cancel this number 8 from the top. And 3 can be cancelled also and leave this to be 3. So what the answer is 11 times 30 times 10 times 3. So it's 11 times 30 and it is 330. And this should be the answer to this. So 11 choose 7 is 330. So if you have 11 symbols and want to make selections of them without regard to order, each selection containing 7 objects, then there are 330 ways how to create such selections.